a battery breakthrough that could change electric vehicles forever. That is how Donut Labs' new battery technology was introduced. Higher energy density, faster charging, lower cost. At least, that was the promise. But during the third major battery test, something unexpected happened. Two serious problems surfaced. And according to early reports, engineers discovered them far later than they should have. This is exactly the kind of situation that can slow down an entire technology revolution. Because in the battery world, laboratory success does not always translate into real-world reliability. What works in controlled testing environments can behave very differently when scaled for mass production. Today we are going to break down the two major issues discovered during Donut Lab Battery Test 3, why these problems were not detected earlier, and what this could mean for the future of next-generation electric vehicle batteries. If you enjoyed deep analysis about electric vehicle technology, battery breakthroughs, and the real engineering challenges behind them, subscribe to the channel right now. Because battery innovation moves fast, but real-world testing always reveals the truth. Let's begin. The first major problem, energy stability. The first major issue discovered during Donut Lab Battery Test 3 was something engineers call energy stability. At first glance, the test results looked promising. The battery cells showed extremely high energy density. That means the batteries were able to store a large amount of energy in a relatively small space. For electric vehicles, this is a big advantage. Higher energy density means longer driving range, smaller battery packs, lower vehicle weight. All of these improvements are exactly what EV manufacturers are looking for. But during extended testing, engineers noticed something concerning. The battery performance was not consistent over time. Keycap 1 unexpected voltage fluctuations. During repeated charge and discharge cycles, the cells began to show unusual voltage fluctuations. In simple terms, the battery output was not stable. Sometimes the power delivery was exactly as expected. Other times, the voltage dropped suddenly before recovering again. In laboratory conditions, these fluctuations might seem small. But in real-world vehicles, unstable voltage can create serious problems. Electric vehicles depend on extremely precise energy management systems. If the battery cannot deliver steady power, it may affect motor performance, charging reliability, overall vehicle safety systems. Even small inconsistencies can become critical when thousands of cells operate together inside a large battery pack. Keycap 2 thermal behavior became harder to predict. Another part of the stability problem involved temperature. During high-performance testing, engineers noticed that some cells heated up faster than expected. Heat is one of the biggest challenges in battery design. If heat spreads unevenly inside a battery pack, it can lead to reduced efficiency, faster degradation, potential safety risks. Modern EV batteries rely on extremely advanced cooling systems to keep temperatures under control. But when battery chemistry behaves unpredictably, designing those cooling systems becomes much more complicated. Keycap 3 why this problem was not detected earlier. One of the most surprising parts of this discovery was how late it appeared during testing. Earlier laboratory experiments showed stable results, but those tests often involve small sample sizes and shorter test cycles. Once engineers began running longer stress tests in Test 3, the instability became visible. This is actually very common in battery development. Early prototypes can look perfect, but extended testing reveals weaknesses that only appear after many charge cycles. The discovery of energy instability alone was already a serious concern. However, the second issue discovered during test May 3rd have been even more troubling, and it could affect whether the battery can ever be mass-produced at scale. Before we continue, if you enjoy deep breakdowns of electric vehicle technology and real engineering challenges behind battery innovation, make sure you subscribe to the channel. The second major problem, manufacturing reality. While the energy stability issue raised concerns, the second problem discovered during Donut Lab battery test May 3rd be even more serious. Because this one is not about performance. It is about manufacturing. And in the battery industry, manufacturing challenges can destroy even the most promising technology. Keycap 1. The scaling problem. In early laboratory testing, battery prototypes are produced in extremely small quantities. Engineers may build only a few cells at a time. These cells are carefully assembled under controlled conditions using specialized equipment. But mass production is a completely different environment. Factories must produce millions of battery cells every year, and every single cell must meet strict quality standards. During Test 3, engineers discovered that the donut lab battery design becomes much harder to produce consistently when scaling up the manufacturing process. Small variations in materials or assembly steps began to affect battery performance. Even tiny inconsistencies could lead to noticeable differences in energy output and stability. This is a major problem for electric vehicle manufacturers. A large EV battery pack may contain thousands of individual cells. If those cells do not behave consistently, the entire battery system becomes harder to manage. Keycap 2 material precision became critical. Another issue discovered during testing involved the precision required for certain materials inside the battery. Some of the advanced components used in the donut lab design must be manufactured with extremely tight tolerances. Keycap 2 investors and industry partners become cautious. Battery innovation attracts a lot of attention from investors and automakers. Electric vehicle manufacturers are constantly searching for batteries that offer higher energy density, faster charging, lower production costs. When new battery technology looks promising, companies begin planning how it could fit into future vehicles. But late-stage technical problems can create uncertainty. Automakers may delay partnerships. Investors may become more cautious, and development teams may need additional funding to continue refining the technology. None of this means the technology is doomed, but it does slow down the momentum. Keycap 3. The battery industry has seen this before. This type of situation has happened many times in the battery industry. Over the years, several breakthrough battery technologies have been announced with huge excitement. But once engineers attempted to move from laboratory prototypes to real-world manufacturing, unexpected obstacles appeared. Some technologies eventually solved those problems. Others required years of additional research, and some never reached commercial production at all. This is why battery development is often described as a long engineering journey rather than a single breakthrough moment. So where does that leave Donut Lab now? Despite the two issues discovered during Test 3, the core idea behind the battery technology may still hold enormous potential. But solving these challenges will require time, engineering effort, and further testing. Before we wrap up, make sure you subscribe to the channel if you enjoy deep breakdowns of electric vehicle technology and real battery innovation. In the final chapter, we will answer the biggest question. Can Donut Lab recover from these two problems? So after everything discovered during Battery Test 3, the big question becomes very clear. Is this the end of the Donut Lab battery breakthrough? Or is this simply a difficult but normal stage in the development process? The honest answer is that both possibilities still exist. Keycap 1 battery innovation almost always hits obstacles. If we look at the history of battery technology, major breakthroughs rarely move smoothly from laboratory testing to mass production. In fact, nearly every successful battery technology faced serious challenges during development. Lithium-ion batteries themselves went through decades of research before becoming reliable enough for commercial products. Engineers had to solve problems related to energy stability, heat management, material degradation, manufacturing consistency. Even after the technology was proven, it still took years for factories to learn how to produce batteries efficiently and safely at large scale. In other words, discovering problems during testing does not automatically mean the technology has failed. It often means engineers have reached the stage where real-world challenges finally appear. Keycap 2, the core idea, may still be valuable. Despite the two major issues discovered during Test 3, the fundamental concept behind the Donut Lab battery may still offer advantages. If the technology can eventually deliver higher energy density, faster charging capability, lower production costs. Then solving these technical challenges becomes worth the effort. Many promising battery technologies require multiple redesigns before they become stable enough for commercial use. Engineering teams often modify materials, adjust internal structures, and redesign manufacturing processes until the technology becomes reliable. Keycap 3. The timeline may be longer than expected. However, solving the stability and manufacturing issues discovered during Test 3 will likely take time. Engineers may need to return to earlier stages of development to refine the design. This could involve adjusting battery chemistry, redesigning internal structures, improving cooling and thermal management, developing new manufacturing techniques. Each change requires additional testing, and battery testing cycles can take months or even years to fully validate. That means the path to commercial production may be longer than early announcements suggested. Final thoughts. The discovery of two major problems during Donut Lab battery test may sound alarming at first, but in reality, it highlights something important about cutting-edge engineering. True breakthroughs rarely happen instantly. They emerge through testing, failure, improvement, and persistence. The Donut Lab battery project may have encountered a serious obstacle, but it may also have revealed exactly what engineers need to fix before the technology becomes viable. And in the world of battery development, that process is often what separates ideas from real-world innovation. If you found this breakdown helpful, make sure you subscribe to the channel for more deep dives into electric vehicle technology, battery innovation, and the real engineering challenges shaping the future of transportation. Also, leave a comment below and tell me your opinion. Do you believe Donut Lab can solve these two problems and bring this battery technology to market? And if you want to understand the next big breakthrough in electric vehicles, watch the next video where we explore how solid-state batteries could completely transform EV range and charging speed. Thanks for watching, and I will see you in the next video.